Welcome back. Next up is IoT veteran Jaap Groot. And he's going to tell you everything about the importance of picking the right antenna for your IoT device. Enjoy his talk.
Welcome to the keynote about virtual antenna technology. As the title says, we believe antennas are critical for IoT devices, and the technology disruption is comparable to what streaming meant for the music and video industry. My name is Jaap Groot and I'm the CEO of Fractus Antennas. Have you ever heard about tuning? Think about the French phrase "c'est le ton qui fait la musique." It's not what you are saying, but how you are saying it. For IoT devices, this is the same as for your guitar. If not tuned well, the music will not be as good as it can be. This is where antennas come in. They make your device deliver the data from the edge to the cloud. For RF engineers, this might sound straightforward. For others, it remains an area of magic. In this presentation, I will try to give you a 15-minute crash course. And keep in mind, experienced people do not need a specific device to tune a guitar. They can do it using their experience, much like RF engineers make radio work in the IoT industry. Let me take you on a journey that I've been going through the last decade, when telematics and M2M became IoT, and share with you some observations that may guide you through the jungle. First of all, IoT solutions must drive value, either directly into the bottom line or to explore new territories. This is why Google invested $3 billion in Nest as a route to the smart home market, or why PTC paid over $100 million for ThingWorx to further penetrate their existing industrial customer base with IoT services and solutions. So if I can give you one recommendation to focus on, it's value creation for your customer. The results will show you which technology choices and deployment requirements will need to be made. These do not need to be all cracked for a proof of concept. Second, longevity is critical. Once those sensors are massively deployed in the field, nobody wants to hear about sunsetting, like what is happening to 2G or 3G networks, because the frequencies are required for higher revenue generating LTE or 5G. CEOs and smart meters need solutions which can last more than a decade, and without the risk of a technology not making it to the mainstream, like WiMAX or Sigfox. And if we talk about long life cycles, we will need everlasting power on the edge. The vast majority of edge sensors is driven by batteries, which all suffer from limitations in peak power or stored energy. This is where antenna efficiency becomes important, as the better the antenna performs, the less power it will require to get data transmitted to the cloud. The last dilemma is around coverage. Here LoRa is flexible, as it allows for public and private networks. Some companies simply do not want their data on a public network, one of the major drivers for private LTE and private LoRaWAN. So in conclusion, the crucial axes all play somehow together and multiple trade-offs need to be made. This is one of the important reasons we worked with TTN on the generic node to provide you with an optimal reference design that includes components from STMicroelectronics, Microchip and Fractus antennas. Driven by the market feedback of you, tens of thousands of IoT fanatics, we have created a solution that has the ability to change IoT, like streaming turned the music and movie industry upside down and brought us Deezer or Netflix. Let me explain. Without taking too much trips down memory lane, I'm sure most of you are in the same situation that I find myself in. A bookshelf full of records and tapes, at least for those with the same amount of grey hair as me. Or for those of a younger generation, plenty of CDs. Not to talk about the actual devices we use to be able to play all these data carriers and turn them into music. My son did a simple calculation after looking at my music collection and came to the conclusion that $10 a month for 50 years, or approximately $6,000, he had all the music he likes, whenever he wants it and wherever he wants it. This is the power of technology evolution, and even has a strong political foundation. Access to the internet at an affordable price is what drives governments to roll out fiber to the home, and some even call data the new oxygen for our economies. Another aspect here is simplicity. We need standards to get mass adoption. As long as we keep too many choices open early on in the design cycle, all the solutions we build will continue to hit the market barriers, whether in terms of cost, and thus not being able to achieve adoption, or in terms of time to market. I assume all of you attending here have experienced this. 12 to 24 months design cycles with huge capex upfront can basically kill any good idea. We, however, as the innovators and disruptors, need to focus on streaming the IoT to its next level. And to do this, we will need to provide answers to topics like multi-radio access, combining the power of several technologies in one edge device that can operate in any frequency band around the world, in order to drive one SKU strategies, and global tracking of assets and labels in the future. Here, we at Fractus Antennas have part of the answer for you. In a minute, I will explain the virtual antenna to you. But don't get me wrong, we do understand we're just a tire to the car. A crucial part though, and if Mercedes would have picked the wrong tires, Lewis Hamilton would probably not have been able to win his 7th championship. Today, when you start developing an IoT solution, for example for a LoRa-centric solution, you will need a sub-GHz antenna. In the end, without a well-performing antenna, your data will never end up in the cloud. The positive side is that there are plenty of antennas available. Just check DigiKey or Mouser and you will find thousands. However, this also creates an issue: which one to pick and how will it perform in terms of antenna efficiency, radiation pattern or TRP. This is why we believe you should consider a virtual antenna for your device from the get-go. And even if you do not know which radios or bands you will end up using exactly, it should be possible to get an idea about performance in your edge device. If you want to understand the full detail, please join the session from our CTO Jaap during this conference. For now, just keep in mind a virtual antenna is not resonant, meaning it does not come with a specific focus for a dedicated frequency band or protocol. Sure, the virtual antenna will need to be tuned for optimal performance. However, that is as simple as tuning your guitar. Even better for you as a developer, the virtual antenna supports multiband, meaning you can use Wi-Fi, GNSS and LoRa at the same time with the same antenna component. And since the virtual antenna is much smaller than others, it fits in almost any edge device, and you will have less space constraints. Yes, we do understand your customers want small devices. Now that you understand the concept, let's explore how virtual antennas disrupt the antenna industry. The concept here is much like what happened in the mobile phone industry. In the late 90s, many RF designers were struggling to get away from the bulky external antennas, and within a couple of years, the whole market accepted fractal designs were the way to go. To keep it simple, fractal is a mathematical derived shape of a metal piece which is in 99% of all mobile phones today, based on IP we developed. However, fractal requires a lengthy and complex design cycle, and mostly requires a relatively large antenna compared to a virtual antenna. Our R&D team came up with the virtual antenna concept many years ago, and we launched our first products in 2015. Nowadays, more than 25 million IoT devices use virtual antennas because they are much more easy to use, do not require any post-prototype changes or customization, and are economically much more viable than other types of antennas. Let me explain how this works using the generic node of TTN. When you are designing the killer IoT device, there are always a few choices to make right from the start. And what we typically see is the antenna is not considered from a system design perspective. This, however, can have a serious impact, as it's clear to you will need an optimal performing antenna to be able to transmit and receive. It's kind of like designing a new car without taking into consideration you will need tires at some point to make the car to be able to drive around. The typical initial choices are made based upon the preferred radio, and then whether to use a module, a modem, a SoC, or go chip down. Second, you choose which sensors are required for your killer device and put them in the design. Now you need to decide where the device will be used. Is it in Europe or the US only? Or perhaps you prefer a global one SKU approach. This choice can complicate matters seriously, as most radios have different operating bands in different geographies. For example, cellular is deployed worldwide in more than 10 frequency bands, and even LoRa has at least 2 major frequency bands, 868 and 915. Once you have done your initial design, you should be able to simulate the performance, potentially using Gerbers or step files. As in this stage of the design process, it is still relatively easy from a design perspective to make changes. This is why we provide a free of charge service called Wireless Fast Track to simulate for you the expected VSWR and antenna efficiency. The design shown here is a multi-band example for EU and US deployments. The main reason for doing so is to make it possible to use the generic node in any LoRaWAN band around the world. Let me dive in a bit deeper and take the generic node as an example. This is important for everyone developing LoRa-centric solutions. We all know the total radiated power, or TRP, is critical to deliver the message from the edge to the cloud. As pictured here, not enough output power means no data in the cloud, and in many cases we do not even know if the device is being put in a proper position. Attenuation of walls or a wearable device close to the human body rapidly reduce the range. In simple words, every 3 dB reduces the range by 50%. So what are the remedies for this? You certainly cannot blame LoRa. The first step would be to ask your network operator to densify their network. Yeah, right. So what do we do next? The only way out is to increase the power and make sure the TRP is what it should be. Or change your design and start over. More about that later. The second important element of the simulation is the radiation pattern. As shown here, satellites are all above us, so you have to make sure your tracking device is pointing in the right direction. Not very user-friendly. And keep in mind, many antennas simply only radiate well in one direction. The solution here is simple. A virtual antenna radiates well in almost 360 degrees. So how do you compare antenna alternatives? You saw in the magic quadrant, we deliberately put all others in the complex and customized expensive corner. Let's take an example of a sticker antenna to show you why you should not always believe what it says on the marketing material. In this example, what we did is take a standard sticker antenna from one of our colleagues, which is recommended with a popular cellular reference design. We then compared the performance specs against the virtual antenna and they appear the same. So from the outset, everything looks comparable, much like you selecting from DigiKey or Mouser an antenna based on its product sheet specifications. We then built a setup in our anechoic chamber and measured the performance of the sticker antenna next to the PCB. And all looked acceptable in terms of antenna performance. Then we took the patch antenna and put it at a 20mm height of the PCB and reduced this distance in 5 steps down to 2.4mm, which is the actual height of a virtual antenna. Remember, you wanted to make your device small, right? We placed the sticker antenna also in different positions, on top, in the middle, and at the bottom of the PCB, as you will do when squeezing in the sticker antenna into the casing. The results in terms of efficiency are in the table and the graph. Whereas the virtual antenna is represented by the red line, all the other lines are the results for each height of the sticker antenna. As you can see, on average, the virtual antenna gives an efficiency of 52%, whereas the sticker antenna at best gets close to 15%. And even worse, the results are not predictable, as they fluctuate with the position of the sticker antenna. For higher frequencies, the impact is less. However, it is safe to conclude the virtual antenna outperforms the sticker antenna in all cases, and you get a much more predictable performance. Be assured, we have this information for many other types of antennas, and if you want to compare, for example, ceramic antennas, you should take a look at their size, typically 10 times bigger, and their required clearance area, which is often much larger, resulting in a bulky device. Let's check what the impact is on your design cycle and cost. We've all experienced this, right? After your prototype is done, some stuff is not right, and you lose valuable time to market whilst development cost rises. And then, when you thought you were done, the test house disqualifies your device as it does not pass certification. And with the current market developments towards multi-radio devices, using for example LoRaWAN and Wi-Fi and GNSS, your design complexity increases dramatically, trying to squeeze multiple antennas into one design. To make a long story short, with a multiband virtual antenna solution, we can dramatically reduce the time to launch and avoid surprises. And as the virtual antenna is a standard component off the shelf, it will always perform alike, and you can integrate them well into the pick-and-place manufacturing process. Convinced or not yet? Keep in mind, we're not new to this. Our R&D team has been disrupting antenna design and developing antenna products for more than 25 years. The majority of mobile phones are using IP invented and developed by our engineers. And over the past 5 years, we've been selected and deployed in more than 25 million IoT devices. Today, there are over 50 ongoing designs with LoRa solutions, and the generic node is a good example of an optimal reference design combining the best what silicon can offer from microchip, ST microelectronics and Fractus antennas. It was a pleasure presenting to you during this keynote. I trust it has been interesting, and we look forward to meet with you at our virtual booth during this event, or even better, in the real world in the near future. If you have 3 minutes to spare and want to win a smartphone, a free antenna design or a boat trip, please go to Screencast, mentioned on the slide, by copying the URL in your browser. Sorry, we could not make it a simple click. For now, enjoy the event and stay safe.